Imagine two vast, shimmering oceans meeting. Do they instantly blend? Surprisingly, no. The Atlantic and Pacific Oceans, despite their close encounter, maintain a visible separation. This intriguing phenomenon has captivated sailors and scientists for centuries. For years, tales circulated about a line where the oceans clashed, creating a dramatic divide. While not entirely accurate, these stories hint at the fascinating truth. The meeting of the oceans is a complex dance of nature's forces. The most obvious reason these oceans don't immediately mix is a geographical one land. The Isthmus of Panama acts as a natural barrier, effectively separating the Atlantic and Pacific Oceans. This narrow strip of land prevents the waters from freely flowing and mingling. Before the Panama Canal was built, ships had to navigate lengthy routes around South America to travel between the two oceans. This physical separation has allowed each ocean to develop its own unique characteristics over millennia. Beyond geography, the composition of the water itself plays a crucial role in the characteristics of our oceans. The Atlantic and Pacific Oceans have different levels of salinity, or saltiness, which significantly impacts marine life and water properties. The Atlantic on average is saltier due to factors like higher evaporation rates and lower freshwater inflow from rivers and streams. Water density is directly affected by its salinity. The saltier the water, the denser it becomes. Saltier water is denser, meaning it's slightly heavier and sinks below less salty water. This difference in density creates a subtle but significant barrier between water layers, preventing them from mixing easily. Imagine pouring oil into water. They don't mix easily because of density differences. This is a simple analogy to understand ocean stratification. A similar principle applies to the oceans, where different salinity levels create distinct layers that maintain their unique properties. Section 4. Oceans in motion. The vast expanses of the Atlantic and Pacific Oceans are never still. They are in a perpetual state of motion, a dance choreographed by nature itself. Furthermore, both oceans are in constant motion, driven by powerful currents, relentless winds, and the Earth's rotation. These forces create a dynamic and ever-changing environment. These currents act like massive conveyor belts, transporting water, nutrients, and marine life around the globe. They connect distant parts of the world, making the oceans a global highway. The Atlantic and Pacific have distinct current systems, such as the Gulf Stream in the Atlantic and the Kuroshio Current in the Pacific, further contributing to their separation and unique characteristics. These currents, while seemingly invisible to the naked eye, play a vital role in regulating Earth's climate. They distribute heat across the planet, influencing weather patterns and even the climate of entire continents. The distinct characteristics of each ocean's currents also impact the marine life that call these waters home. From the smallest plankton to the largest whales, every creature is affected by the movement of the ocean. Section 5. Blending borders. While the oceans might appear dramatically different at their meeting point, it's important to remember that this boundary is not absolute. Over time, some mixing does occur. Winds, waves, and turbulence gradually blend the waters along the edges. Think of stirring cream into your coffee. At first, they remain separate, but with continued mixing, they eventually blend. Similarly, while a distinct line might be visible, the ocean's boundaries are dynamic and constantly evolving. Section 6. Why it matters: a connected world. Understanding why the Atlantic and Pacific Oceans don't readily mix might seem like a simple curiosity. But this phenomenon is more than just an interesting fact. It serves as a gateway to understanding the complexities of our natural world. However, it highlights the intricate interconnectedness of our planet's systems. The way these massive bodies of water interact, or don't, reveals much about the delicate balance that sustains life on Earth. Ocean currents, salinity, and geography are all part of a delicate balance. These elements work together in a finely tuned system that regulates everything from weather patterns to marine biodiversity. Disrupting this balance can have far-reaching consequences for marine ecosystems, global climate patterns, and even our own lives. For instance, changes in ocean currents can lead to extreme weather events, while shifts in salinity can affect marine habitats. Recognizing these connections fosters a deeper appreciation for the natural world and the importance of protecting its delicate equilibrium. By understanding the interconnectedness of our oceans, we can better appreciate the need for conservation efforts and sustainable practices to ensure the health of our planet for future generations.